In this lecture, we're going to talk about the stoichiometry. What is stoichiometry? Basically, stoichiometry is a Greek word in which stoichein means elements and metron means measurement. As the word stoichein and the metron combinedly made a stoichiometry, we can see that we can combine these two things, element and measurement. So we get that it is the study of relationship between quantities of reactants and product during the chemical reaction. Why we use it? Like just suppose we have to make a building. To make a building, we need some material or something. Now, to calculate that thing, calculate those things, we need calculation. Like just suppose we need 121 blocks to make a building. For that, we have to calculate that raw material. As it is, when we are making a NaCl, we need Na, sodium plus chloride. How much of sodium and how much of chloride? One sodium atom and one chloride atom. Now, this is stoichiometry, the measurement of the reactants and also the product, which is NaCl, the product. Now, this is called stoichiometry. We're gonna just talk about the calculation but with respect to chemical reactions. What is mole? Now, according to stoichiometry, it is the used to measure things. Now, to measure things, of course, there would be a unit that to measure that. Now, there is some unit mole here. Mole is defined as any formula unit, atomic mass or molecular mass measured in gram instead of AMU, that is unit of the amount of substance. So, that is called the mole. It is a convenient way to calculate the amount of particles in an object. Mole is SI unit of amount of substances, which is written in the 7 fundamental SI units. Now there are two types. I had just taught you that mole is used for molecular mass as well as atomic mass. So how can we just calculate molecular mass? Now just see H2O. Now here H2O is equal to 18 AMU as H is equal to 1. Atomic mass of H is 1, and here we have to just multiply the 2 from the atomic mass of the atom. And I think we can't just remember what's the atomic mass of the oxygen, but we have to just multiply that. Now, after multiplying that, we will just get 18 AMU. That's the molecular mass of that. Like, we have to just put the atomic mass in the in the formula unit, so we can get the formula mass. Like NaCl's formula mass is 23 AMU, that is their actual mass. NaCl, which is sodium chloride, its mass is 58.5. Here we have to just add the mass of the Na, which is 23, to the mass of the chloride, and we will get 58.5 AMU. Now how can we represent this in mole? H2O is equal to 18 AMU as written. So we're gonna just take this 18 AMU as 1 mole. If we are making 2 particles of H2O, we're gonna say we have to take 2 moles of that. Now this is a conventional unit. As written NaCl or Na, this is all about today's lecture.